In this video, as we solve these rational equations, the fractions will disappear, leaving us with quadratic equations to solve. Remember from the last video that to get the fractions to disappear, we need to have the LCD, the least common denominator. And to find that, we need to factor our existing denominators. So for our first denominator, when I see a linear factor with no GCF to pull, I'm just going to go ahead and put this in parentheses. So for the x plus 2 as well as for the x plus 1, there's no factoring to be done. For this trinomial though, you can think of an x box. Numbers that multiply to 2 and add to 3 are just going to be 2 and 1, which conveniently are the same factors we saw before. Like I said, these problems will be engineered to typically turn out that way. So if you're having trouble factoring your trinomials, thinking of the right numbers, look over here for the right numbers. They're typically over there. So now looking at your factorizations, we should be able to see the LCD. The LCD takes all the factors that show up. In this case, that's the x plus 2 as well as the x plus 1. I need both of those for my LCD. Now, while we're at it, let's also identify who the restricted values are. Those are the values that would make the denominators turn to 0, which is not allowed because it creates undefined values. So the restricted values, those ones who are off limits, let's see if we can find those before we begin. The restricted values would be those which make the denominator turn to 0. So what value of x would make x plus 2 equal 0? That would be negative 2. And what value of x would make x plus 1 equal 0? That would be negative 1. Now if I ask that same question over here, I already answered those questions over there. So I already know that here x being negative 2 would be a problem and x being negative 1 would be a problem. So those are my two restricted values. After I go through my entire process of solving this equation, if I come up with a solution that says either negative 2 or negative 1, I will have to throw those out because they wouldn't work. They're off limits. So now let's take a look at solving this equation, taking this rational equation and multiplying everything by the LCD to make the fractions disappear. And again, I'm going to have to work with very, very small writing here because I don't have a heck of a lot of room on this board. So bear with me here. I'm going to take that first fraction, 8 over x plus 2. I'm going to multiply by the LCD, x plus 2 times x plus 1. And again, I like to write that LCD over 1 so that it's a fraction times a fraction. Makes it easier to work with. Next, I have plus this fraction x over x plus 1. He also needs to get multiplied by the LCD, which again is x plus 2 times x plus 1. And I have now equals on the right side. I have 5x plus 2 over, and I'm going to write the factored version of that denominator. It'll make it easier to see who cancels. So x plus 2 times x plus 1. And just as everybody else was, this guy also gets multiplied by the LCD, x plus 2 times x plus 1. So in terms of comparing this first step to the original, everything copies from the original except this LCD is now multiplied onto everybody. And again, that step feels like it's a lot of writing, but it's worth that step because now I can visually see who divides out, how does that denominator disappear, and what's left when it does. So over here, the x plus 2's will divide out here, x plus 1 will divide with x plus 1, and here both the x plus 2 and the x plus 1 will divide out. And now that that has happened, every single denominator has reduced to 1, so this is no longer a fraction at all. I have from the original numerator 8 that I'm now multiplying to the leftover x plus 1. And then I have plus. Originally there was an x there, and now I'm multiplying by the leftover x plus 2. Then comes an equals. I had 5x plus 2 originally, And that's not getting multiplied to anything except for a boring 1, so I'm going to take that and multiply it by 1. So now what I'd like to do is to clean this up a little bit. Yes, I have eliminated all my fractions, but I need to make sure that I can solve for x. Since he's trapped in parentheses, let's distribute to release those parentheses here. So 8 times x will give me 8x. 8 times 1 will give me 8. X times x will give me x squared. X times 2 will give me 2x. And on the right side, 5x plus 2 times 1 is just 5x plus 2. I don't actually need to say times 1. But we can more easily see now that the fractions are gone, this is now a quadratic equation identifiable because of the x squared. So if it's quadratic, let's push everything to one side. Before we do that, maybe we can clean this up a little bit. Can we maybe put this in order and combine like terms? So I would put x squared first, and then I would ask how much x is on the left side. I have 8x plus 2x, which together combines to give me 10x, and then I have the plus 8 for my constant. So there's the left side cleaned up a little bit. And now what I'd like to do is, again, I have a lot of techniques I can use for solving quadratics, but what you'll find is that these are designed like they were in the radical equations. These rational equations are designed to work very well with factoring. So what I will do is set this equal to 0 and factor to solve. So let's relocate the letters. Let's take the 5x, which was positive. Let's take that and relocate it to the other side using subtraction. While we're at it, we want to multitask when we can. Let's take this positive 2 and relocate it to the left using subtraction as well. This should set this equal to 0. So now I have x squared, and then 10x minus 5x is 5x. 8 minus 2 gives me 6. And now everything on the right side has canceled out, leaving me with 0. So now I have a trinomial set equal to 0. And I want to factor that trinomial. So think about the x box again. What's going to multiply to 6 and add to 5? And those numbers are 2 and 3. 2 times 3 gives me 6, and 2 plus 3 gives me 5. And I'm going to go ahead and just throw those into parentheses here, the 2 and the 3. I can throw them into parentheses because there was nothing in front of x squared. And now if something times something is 0, one of them's got to be 0. If x plus 2 were 0, then x would need to be negative 2. And if x plus 3 were 0, then x would need to be negative 3. And so from this quadratic, we found these two solutions, which sounds good, but remember, with fractions, there can be problems. We had restricted values that we had to watch out for. We said that if a number would make a denominator turn to 0, it would be undefined, and so that would be a problem. So we already notified ourselves of what the restricted values would be. Negative 2 and negative 1 are off limits. And so here, when I said that negative 2 was one of my solutions, I'm going to have to cut that out because it is restricted. It is off limits. And so my actual solution is just x equals negative 3. Negative 3 was not off limits. It's not going to make the denominator turn to 0, so we're happy with that answer. Now you're more than welcome to take that negative 3 and actually plug it in everywhere you see an x and crank it out and see if it works, but you don't have to go that far. The only thing you have to watch out for is that you do not equal a restricted value. You just need to make sure the denominator won't turn to 0. And in this case, the negative 3 plus 2 is not 0. Negative 3 plus 1 is not 0. And if those aren't 0, they certainly won't multiply to 0. So we're good with just the negative 3. Let's try a couple more examples where, again, the fractions, when eliminated, reveal to us a quadratic equation. In this example, we start off with an equation that actually mixes a fraction with other things that are not fractions. So let's see how to go through this example. Again, we want to find an LCD. Now in this particular case, that's actually very easy to find because there's only one denominator, and that is x. So here our LCD is x. While we're up here though, before we begin, let's also make sure we identify those restricted values. Again, these are the values that would cause the denominator to turn to 0, which is not allowed. In this case, the only way for this denominator to become 0 is if x itself were 0. So 0 is off limits. We may not let x equal 0 in the end. Okay, so what we're going to do is we're going to multiply everything through by the LCD to make the fractions disappear. But this is why I want to show this example to you. A lot of times what I'll see is students will multiply just the fraction by the x because that's the problem they want to get rid of. But remember that as we're solving equations, we have to be balanced about it. Everything has to get multiplied by the LCD, every term on both sides, whether or not it's actually a fraction. So let's take all of our original stuff. 2 is an original term, and he needs to get multiplied by the LCD. Now in this case, I'm not going to bother writing the LCD over 1 because my original term is not a fraction, so there's no reason for me to make it look like a fraction. The second term, however, is a fraction originally. Because that's a fraction, let's now multiply by the LCD where the LCD does look like a fraction. So I'm still multiplying by x, I'm just making it look like x over 1. So if it is a fraction, put the LCD over 1. If it's not a fraction, just leave the LCD as a whole number. The key here, though, is that everybody on both sides of the equation does have to get multiplied by the LCD. So everything is times x. So this should look very similar to the last several examples where each term is multiplied by x. Now what the point of the LCD is to cancel the denominators, but I had no denominators except for right here. And you'll notice that the x that was in the denominator reduces or divides out with the x that's in the numerator. And so these guys were never fractions to begin with, and now this guy is no longer a fraction because the denominators are now 1s. So let's see what we've got here. We've got 2 times the x plus, we have 6 times now a 1. We have x times the x, and we have 7 times the x. So we have a lot of stuff getting multiplied by x here. So 2 times x is 2x. 6 times 1 is 6. On the right side, x times x is x squared. And 7 times x is 7x. And so we can now see that the fraction has been eliminated. We now have a quadratic equation. Let's go ahead and set this quadratic equation equal to 0. We will factor to solve it. Now if I'm going to set it to 0, I'm going to go ahead and push everything to the right because my highest coefficient, or my highest term here, x squared, I want to leave him positive. If I relocate him to the left, he'll turn negative. So I'm going to relocate everything to the right instead. So let's take this 2x, which is currently positive. Let's subtract him from both sides to relocate him. And while we're at it, let's multitask and also relocate this 6. Since he was positive, I'll subtract 6 from both sides. So now there's nothing on the left side. It's canceled out to 0. On the right, I have x squared, and then 7x minus 2x is 5x. And then I have that negative 6. Now, if you're uncomfortable with 0 on the left, you can simply just say equals 0 on the right. Remember that equations can be read both directions. Equations, the equal sign just says the same as. So if 0 is the same as this trinomial, it would stand to also reason that this trinomial is equal or is the same as 0. It doesn't matter what order you say it in. So if you are more comfortable with the 0 on the right, go ahead and put it there. But now that this equals 0, let's go ahead and factor. I'm looking at a trinomial, so I can think about the x box again. Numbers that multiply to negative 6 and add to 5 would be positive 6 and negative 1. And I'm throwing them right into parentheses again because there's nothing in front of the square guy. So now if something times something is 0, one of those has to be 0. If x plus 6 is 0, that means that x must be negative 6. If x minus 1 is 0, that means that x must be 1. But before I say that's my answer, I gotta go back and look at my restricted values to just make sure that I'm not allowing my answer to be an off-limits number. Originally, we said 0 was the only bad guy. He was the only one that would make a denominator turn to 0. And I've not said that x is 0 here. So I'm safe with both of these solutions. Neither one of these will make the denominator say 0. So this particular one had 2 examples. Let's look at just one more, again, where we mix the fractions with the non-fractions to see how that goes. So here's our last example of solving a rational equation where, again, we're mixing terms that are fractions with terms that are not. And let's see how we go through this. So again, the key to making the fractions disappear is the LCD. So I do need to find the LCD. In order to find the LCD, it's helpful to see these denominators factored. Now, to factor x plus 3, there's really not a whole lot to do. I'm just going to put parentheses around it, though, so that I see that x plus 3 is a factor. It's not about the x or the 3 as individual terms. So the LCD will be x plus 3. It's the only denominator that shows up at all, so it's an easy LCD to find. Beyond that, though, let's also find the restricted values. Again, these are the values that are off limits. They are the ones who would make the denominator say 0, which we cannot have. The only denominators in question are these two, and they happen to be the same. The value of x that would make these denominators say 0 is -3. So if at some point near the end I get a solution of -3, I have to get rid of it because it's off limits. It would make the denominator say 0, which would be a problem. So now that I kind of know what my LCD tool is going to be and what I need to watch out for at the end, let's go ahead and cancel denominators. So each term from the original equation will get multiplied by this LCD. So that x needs to get multiplied by the LCD x plus 3. Notice, if it wasn't a fraction to begin with, I just write the LCD as not a fraction. The second term was a fraction, so I had minus 6 over x plus 3. Since that is written in fraction form, I will multiply by the LCD in fraction form. So I'm just kind of matching the format. If it's not a fraction, not a fraction. Fraction, fraction. Now I have equals. Here comes another fraction, 2x over x plus 3. I will multiply that again by the LCD. We want to maintain the balance, so whatever we're doing to one term, we're doing to all terms on both sides. Last, we had plus 2, which was not written as a fraction. So when I multiply by the LCD, I won't bother putting it over 1. The whole point of the LCD is to cancel the denominators out. And so it only affects those terms which were fractions to begin with. So this x plus 3 in the denominator cancels with the x plus 3 in the numerator. Same here, the x plus 3 downstairs with the x plus 3 upstairs. And now the things that weren't fractions were never a problem, but the ones that were no longer are because their denominators have canceled away. So now we have x that needs to get multiplied to x plus 3. We now have -6 that's getting multiplied to just a 1 now. We have 2x, which is only getting multiplied to 1 now. And we have a 2, which is getting multiplied to the x plus 3. So where it makes sense to, let's go ahead and distribute to get rid of parentheses. So x will distribute to the x and the 3. And over here, the 2 will distribute to the x and the 3. So x times x is x squared. X times 3 is 3x. -6 times 1 is -6. On the right side, 2x times 1 is 2x. 2 times x is 2x. And 2 times the 3 is 6. Before we start pushing things around, let's combine like terms on that right side. The left side looks nice as it is, already in descending order, no like terms to combine. But on the right, 2x plus 2x can be combined to give me 4x. And so now I have this nice quadratic. If I'm going to solve it by factoring, I need to push everything to one side. So let's relocate these two terms. Since this 4x is currently positive, let's subtract 4x from both sides to relocate it. And while we're at it, let's take this 6 and we will relocate it using subtraction. So now we have x squared. 3x minus 4x is negative x. Negative 6 minus 6 is negative 12. And the right side is now canceled out to 0. So we've set our equation to 0, and now we can factor. To factor the trinomial, I'm thinking about that x box again. Numbers which multiply to negative 12 and add to negative 1. I see negative 4 and positive 3, and I'm going to throw those right into parentheses because there was nothing in front of x squared. And if something times something is 0, one of those factors must be 0. If x minus 4 is 0, then x must be 4. And if x plus 3 is 0, then x must be negative 3. But before I box that, we make sure that it's not off limits. So go back to our restricted values. We said x could not be negative 3. Negative 3 was off limits because negative 3 plus 3 would create a 0 in that denominator, which is a problem. So let's cut the negative 3 out. It is an extraneous solution. This is now going to show only one solution, x equals 4. So we've seen several examples now. Sometimes we mix fractions with whole numbers, sometimes it's fractions everywhere. But again, as we're solving these equations with fractions, the key is finding the LCD and multiplying it to every single term. Whether it was a fraction or not, we maintain balance by multiplying it to everyone. But the LCD is special because it causes denominators to drop out. The fractions are gone, it makes it much easier to solve. We only have one more video, one more topic to go through in the whole class for this whole semester. We're going to be looking at quadratics and form in the next video.